Write this down. So flipping a coin 3 times. What is the probability that all 3 are tails? This is not what we just did. What do you think the probability is that all 3 are tails? So where did you get 1 and 8? 1/2 times 1/2 times 1/2, because you have half for the first one, half for the second one, half for the third one. Some people may have thought that way, and some people might not have yet. So I want to, that one, some people can think of 3 right now. This one, without doing much, is going to be a little bit more difficult. So I want to take a step back and think about this problem first. So we have to think about this problem one event at a time, or one trial at a time. How many trials are there going to be? 3, because I'm flipping the coin 3 times. So on our first coin flip, what are my options? Now, when I do my second flip, it could have already been a heads, or it could have already been a tails, right? So branch from each of those. Now this second one can be heads or tails. And then I have to do it again for my third flip. So at the bottom, how many do I end up with down here? 8. We can write this out as a sample space. So my first path that I could have gone was what result? All 3 are heads. My second result would be what? Heads on the first flip, heads on the second flip, tails on the third flip. So I'm just reading down in order. So then I'm out of habit, so you gotta write that. Out of habit, a lot of the times I do that. So I'm writing how many outcomes are in my sample space. Yeah. So the way we find out the probability that exactly one of them was a tail is through this process. Technically, the way we found the answer to the first one is also exactly through this process. So how many different outcomes are there? 8. How many of them had all 3 of them being tails? 1, which was the same conclusion we came up with earlier. There are 8 outcomes. How many of those outcomes are all 3 tails? 1. So 1 of 8. Now, it doesn't matter now, but eventually it can change. What do I know about the probability of being heads and the probability of being tails? They're the same. So this chart happens to be that all of the outcomes are the same each time. So now we're going to take this and put this in a probability table. Just slide it up so I have room to keep writing with that. So let's do it with, let's let our event being the number of tails. I'll just say let t be the number of tails. Sure, that backwards. So then I can do a probability table as t and probability of t. So I flip a coin 3 times. What are my options for the number of tails I can get?
0, 0.
So I've got all of my outcomes written up here. Of my 8, how many of them have 0 tails? Just this one out of all 8. We already said how many of them have all 3 of them tails. One out of 8. How many of them have exactly 1 tail? This one, and this one. So there are 3 of them out of the 8 that are exactly 1 tail. I can count the same thing here. But if I have 3, I have 4, I have 5, how many are left? Which is 3 blank ones left. So this is called a tree diagram. We just made a tree diagram to display our information.
No, that one. Like the range.
Yeah, the thing up top. So this part up here that I can't scroll down now is tree diagram. This is called what? Sample space. What is this called? Probability table. What does it mean? What's our word for that? So this is an event. What is this? Complement. What is the rectangle? Sample space. What is this? Mutually exclusive. What is this? Not mutually exclusive. What is this? What does that mean? Or always mathematically means I do what? Add. It means I sometimes subtract only if events are overlapping, not mutually exclusive.